we alone in the universe? This is a question that humans have grappled with for millennia. However, NASA is bringing the search closer, and it's announced an exciting discovery. There are 36 alien civilizations in our Milky Way. However, NASA is warning that this discovery may mean destruction. Why can this discovery cause destruction? What do these alien civilizations look like? Join us as we dive into NASA's recent announcement that there are 36 alien civilizations in our very own Milky Way galaxy. How long have humans been on the Earth? The answer actually depends on where you prefer to start reckoning from. If you limit the scope to modern humans, then we've been around for about 200,000 years, with civilization as we know it even much more recent at about 6,000 years old. However, using another way of counting, we can extend the history to millions of years ago. The first tangible link to humanity started around 6 million years ago with a primate group called Ardipithecus. This started in Africa when this group began the path of walking upright. This was traditionally an important turning point because it allowed for the more free use of their hands for tool-making, weaponry, and other survival needs. The Australopithecus group dominated between about 2 million and 4 million years ago with the ability to walk upright and climb trees. Next came Paranthropus, which existed between about 1 million and 3 million years ago. The group is distinguished by its larger teeth, which allows for a more diverse diet. The Homo group, which covers our own Homo sapiens species, began arising more than 2 million years ago, distinguished by bigger brains, more tool-making, and an expansion out of Africa. Our species was distinguished about 200,000 years ago and managed to survive and thrive despite climate change at the time. While we started in temperate climates about 60,000 to 80,000 years ago, the first humans began straying outside of the continent in which our species was born. However, while intelligent life evolved on Earth, was there any chance that the same was happening in other parts of the universe? Many people find it hard to believe only the Earth out of the whole universe could support life. The first serious speculation about intelligent life off of the Earth, or in other words, aliens, goes back to the atomist speculations popular among Epicurean philosophers in ancient Greece and their Roman disciples. Two philosophers, Democritus and Epicurus, thought of the universe as the result of a chance jostling of atoms and regarded it as highly likely that there were other worlds out there and that they were inhabited. Then there was Epicurus's disciple Metrodorus of Chios, who contended that the idea of our world being the only one is as unlikely as if a single ear of wheat grew on a vast plain. As the Roman Epicurean poet Lucretius put it, nothing in the universe is unique and alone, and therefore in other regions there must be other Earths inhabited by different tribes of men and breeds of beasts. Don't these sound like something you expect to hear in the modern age? However, those ideas did not flourish at the time because they were simply too radical for the time. It was too abstract for a period where people preferred what they could see and hold. However, by the 15th century, the idea was back within the intellectual circle. Nicholas of Cusa, for example, argued, life as it exists on Earth in the form of men, animals, and plants is to be found, let us suppose, in a high form in the solar and stellar regions. Rather than think that so many stars and parts of the heavens are uninhabited and that this Earth of ours alone is peopled, and that with beings of an inferior type, we will suppose that in every region there are inhabitants, differing in nature by rank and all owing their origin to God, who is the center and circumference of all stellar regions. Nicholas's idea of extraterrestrial life was different from the Epicureans in a major way. He was talking about humans, animals, and plants that better fit what we describe as aliens today, despite the religious connotations. The modern man still thinks about the possibility of other intelligent beings somewhere in the universe. The idea is just too tantalizing to be ignored. However, we are aided today in the search for extraterrestrial life by sophisticated equipment that can send and listen out for signals that could be emanating from aliens. NASA has been active in the search for intelligent life in space for many decades. The space agency has been testing a battery of instruments that robots and astronauts will one day use to search for life on other planets. These tools are designed to efficiently analyze on the spot the composition of the surface of planets, moons, and asteroids. This will allow for quick adjustments to exploration plans and well-informed decisions about which few precious samples explorers can afford to return to Earth on a spacecraft of limited size. NASA engineers test these tools using a technique. They deploy the tools to locations on Earth that are suspected to be similar to conditions on other planets. This is where we confess we are jealous of these guys, as some of these locations are quite exotic. They have, for example, worked in landscapes such as the Potrillo volcanic field in south-central New Mexico. There, the desert geology that was shaped over millions of years by Earth's volcanic and tectonic forces closely resembles our moon's. This is why Potrillo has served as a geology training ground for astronauts dating back to the Apollo era. They have also been to the active Kilauea volcano in Hawaii, where lava cools to form basaltic rocks similar to those on Mars. The idea behind this is that early in its history, Mars had giant active volcanoes that dwarf what we have on Earth right now. NASA is testing a tool that uses light detection and ranging technology, or LiDAR, to map terrain in 3D, which allows explorers to understand the topography in a radius of 200 meters around them. The way LiDAR works is pretty simple. It maps surface geometry and elevation by sending out pulses of near-infrared light at millions of points on the ground and calculating how long it takes to bounce back. It then converts that time to distance based on the speed of light and thus scans variations in elevation. LiDAR technology was developed decades ago and is now used extensively on Earth in fields ranging from volcanology, the study of volcanoes, to driverless cars. Laser technologies similar to LiDAR developed at Goddard have been used on orbiters to measure the topography of planets, including Earth, but terrestrial laser scanning has not been operated on any other planet yet. One future scenario involves rovers using this instrument to help human explorers find habitable tunnels below the surface of the Moon or Mars that were formed billions of years ago by flowing lava. NASA is also developing a gizmo called the Handheld X-ray Fluorescent Spectrometer that can identify the elements objects are made of with the help of high-energy X-rays. Equipped with this compact tool, astronauts can quickly evaluate in under 2 minutes the composition of their immediate surroundings. The fluorescent spectrometer emits X-rays when placed against a point on the surface of a planet. The incoming X-ray kicks an electron out of close orbit around the nucleus of an atom, triggering an electron from an outer orbit to replace it, thereby returning the atom to equilibrium. This maneuver creates more X-ray energy, or fluorescence, which is detected by a sensor in the instrument. The working principle here is that different elements in rocks and soils produce different energy signatures. These energy signatures can be plotted on a graph or displayed in a data table. With these, researchers can work out the composition of an object based on the pattern generated on the screen of the instrument. This spectrometer can pass for a retail price scanner weighing just 4 pounds, but of course, it is much more powerful. It is powered by a rechargeable lithium-ion battery, has a large-area silicon drift detector that senses and measures X-rays, and an anode tube that produces X-rays. And thanks to a new study, NASA has now made a startling claim about extraterrestrial life. We may be sharing our Milky Way galaxy with 36 other civilizations. The researchers found that all these civilizations could be capable of really long-distance communication. The basic assumption for this theory is that intelligent life develops on other planets similar to how it developed on Earth. To arrive at the figure they published, the team of researchers considered 2 major astrobiological Copernican limits, or conditions that such an intelligent civilization would depend on. For one of these limiting factors, the researchers used Earth as the basis. Life on Earth kicked off about 4.54 billion years ago, so they assumed that intelligent life most likely forms in less than 5 billion years. What about the second limiting factor? This one focused on stars. The scientists estimate that a planet with intelligent life would still orbit a star like our own. That sounds reasonable, as life managed to take off on Earth and it orbits around the Sun. This potential Sun-like star would have a metal content equal to that of the Sun. Of course, the Sun is quite metal-rich. There is also the technological capability to consider. The team figured that the number of intelligent civilizations depends on technological capability, but more specifically, it depends on how long they've been sending out some sort of signal into space. This signal could be anything from radio transmissions from orbiting satellites to television. To get the idea, we can use humans. Our civilization has been technologically advanced for only about 100 years. Using these criteria and making these assumptions, the researchers arrived at an approximate estimation of the number of intelligent civilizations that could exist in the Milky Way. The final figure says that there should be about 36 active civilizations in our galaxy, but don't think they are close or near each other. The average distance to these alien worlds would be approximately 17,000 light years. The next question is, how likely are we to encounter any of these civilizations? That is where the Fermi paradox comes in. Enrico Fermi, a Nobel Prize-winning scientist, made a point that became a paradox during a lunchtime chat in 1950. He said given that our solar system is quite young compared to the rest of the universe, roughly 4.5 billion years old compared to 13.8 billion, and that interstellar travel might be fairly easy to achieve given enough time, Earth should have been visited by aliens already. What Fermi was trying to say was that any civilization with a modest amount of rocket technology and an immodest amount of imperial incentive could rapidly colonize the entire galaxy. Within a few tens of millions of years, every star system could be brought under the wing of an empire. You might be thinking, tens of millions of years may sound like a long project, but in fact, it's quite short compared to the age of the galaxy, which is roughly 1,000 times more. Fermi would die 4 years later, but his paradox has lived on. Other scientists have had the job of fleshing out the paradox. For example, Michael Hart argued that intelligent aliens could already have visited Earth at some point in our planet's history, unless they started their journey less than 2 million years ago. He thought the apparent lack of such visits was most likely due to the lack of intelligent aliens, but he suggested 4 other potential explanations for why aliens have not shown up yet in these parts. One is that there is a physical difficulty that makes space travel infeasible. This physical difficulty could be related to astronomy, biology, or engineering. 2 is that aliens simply decide to shun us and never visit us. 3 advanced civilizations beyond Earth arose too recently for aliens to reach us. And 4 aliens have visited Earth in the past, but we managed to miss them. Another scientist, Frank Tipler, took it up from there and published a study on getting the resources to fund interstellar travel. His MO was that some self-replicating artificial intelligence could navigate from one star system to another by creating copies of itself en route. However, evidence for such outlandish machinery has never been found on Earth, so Tipler argued that we are likely alone in being intelligent beings in the universe. But one important point was that things had changed greatly since the time Fermi proposed his paradox in 1950. Back then, the only planets scientists knew about were located in their own solar system, but in 1992, astronomers saw planets orbiting a pulsar. A few years later, astronomers found the first exoplanet around a sun-like star. Today, about 5,000 exoplanets have been found, with more turning up every year. The vast number of alien worlds suggests that life may be plentiful throughout the cosmos. Over time, with better telescopes like the James Webb Space Telescope, scientists will probe the chemical compositions of some nearby exoplanets' atmospheres. Notice that nearby is a relative term because the closest known exoplanet, Proxima b, is about 4.2 light-years away, and that is about 25 trillion miles or 40 trillion kilometers. What we need to do is to understand how often rocky planets exist in the habitable zone of their parent stars. The habitable zone of a star is the range of orbital distances in which water can exist on an exoplanet's surface. Of course, the presence of water does not mean a planet is habitable, as there are other factors to be considered, like the host star's activity and the planet's atmospheric composition. But even with these extra factors, there are still lots of room for potentially habitable planets. Scientists keep discovering exoplanets in the sweet spot known as the habitable zone. Astrobiology is one of the avenues astronomers are exploring to find life in deep space. They do this by studying microorganisms in extreme locations on Earth, trying to find the telltale signs of these microbes on other planets like Mars. But Fermi's paradox is not dealing with microbes, it deals with supposedly intelligent aliens. So anybody attempting to solve it must work out how common life evolution is on alien planets. They also have to know how often alien life gains the ability and the desire to communicate with outsiders and to go star hopping. The Drake's equation is used to estimate the number of intelligent and detectable alien civilizations. This is what the equation looks like, where n is the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable, r star the rate of formation of stars suitable for the development of intelligent life number per year. FP is the fraction of those stars with planetary systems. NE equals the number of planets per solar system with an environment suitable for life. FL is the fraction of suitable planets on which life actually appears. FI is the fraction of life-bearing planets on which intelligent life emerges. FC is the fraction of civilizations that develop a technology that produces detectable signs of their existence. And L is the average length of time such civilizations produce such signs in years. Could it be that life is too fragile to survive for long? For instance, a study shows that the early part of a rocky planet's history can be very conducive to life, which may commonly emerge starting just 500 million years or so after the planet cools down and liquid water becomes available. It is actually a wild thing for life to survive between the early heat pulses, freezing, volatile content variation, and runaway positive feedback. Rocky planets are the Wild West at that stage. Most life forms can't make it out of that phase, so life may be rare not because of being difficult to start, but being hard to maintain in the first few billion years. But then, the problem may actually come later. There are theories that civilizations may tend to extinguish themselves soon after becoming technologically competent, that is, self-destruction of some kind. Interestingly, there is support for this theory right on our own planet. Humans came close to nuclear war during the Cuban Missile Crisis in 1962. Russia is also threatening to use its nukes in its current war in Ukraine, which may trigger a nuclear Armageddon as the US has vowed to retaliate. If Russia feels cornered and attempts to detonate a nuclear bomb in Ukraine, that may signal the end of humanity, and we would have fallen victim to our own advanced technology. There is also climate change due to human activities that could be what dooms the whole planet. And there is also an alien psychology angle to all of this. That's right, aliens may turn out to have emotions. As mentioned earlier, aliens may simply want to keep to themselves. So even if they have the capacity to communicate, they might just not feel up to it. Perhaps earlier encounters with other civilizations may have left a bad taste or been a horrible experience. In fact, the late Stephen Hawking advised that humans should not advertise their presence in the cosmic neighborhood. Perhaps it's best to take Hawking's advice. Let's hear what you think of finding aliens in the Milky Way galaxy in the comments section below.